श्रीमती JJ पर शायद प्रोग्राम में कोई आदमी था, मैं अभी गाड़ी लेकर आता हूँ। मैंने तुमसे कहा था कि किन चोट का हाथ होगा और ले सकते।
Hello, everyone, please mute yourself. Hello, please mute yourself. It's humble request to every participant. Please mute yourself.
Good morning, everyone. Welcome to the webinar on application of big data for engineers, organized by the Department of Electronics and Telecommunications, Bharati Vidyapeeth College of Engineering, Navi Mumbai. As you all know, big data analytics is about examining large data sets to uncover hidden patterns, market trends, and customer preferences. These findings help us in effective marketing, better customer service, operational efficiency, and competitive advantages. Big data analytics is a fast emerging field in the IT industry, and all major companies across various domains use their services. It has excellent job opportunities, and our speaker today, Dr. Selvaraaju Murugesan, an industry expert in this domain, will share his insights and case studies for us. Before we start the session, a quick introduction about today's speaker. Dr. Selvaraaju Murugesan received his Bachelor of Engineering degree in Mechatronics Engineering from Anna University in 2004. He was a gold medalist in BE and a Master of Engineering degree from La Trobe University, Bandura, Australia in 2008. He received his PhD degree in Electronics Engineering Department, La Trobe University in 2012. During his previous employment at Transport Canberra and City Service Directorate of ACT Government as Senior Director, Innovation, Data and Analytics, he has undertaken many data analytics projects. He was responsible for implementation of data management practices and delivering analytics functions to the internal business units and to help them achieve organizational goals. His interests are in the area of data science, open data, hackathon, and business strategy. I now invite Dr. Selvaraaju to speak on big data analytics and enlighten us with his knowledge. Selva sir, you can start the session.
Thank you very much, Dr. J.Jeyavel, for the kind introduction. And I would like to welcome all the participants to the webinar as well. Before I proceed, are you able to see my screen, my slides?
Yes, sir.
Excellent, cool. I'm just looking at. Look, is there a chat function enabled? Look, what I'll do is I don't think chat function is enabled, but anyway, what I'll do is I'll share the presentation slides with after I complete, or I'll put the link in the slides as well so that you can download the content. You know what? Let me do that. Yeah. So if you, I think the content page is there. So if you type ecupload.io/7HAUHO, you can download this presentation. By the way, this presentation is released under CC BY license, which means you are happy to distribute, change, modify the content. The only thing is you have to attribute, put some attribution. Yeah, cool. Anyway, before I kickstart, I just want to show you something and then see how many people recognize this. By the way, how many people recognize this device? I don't know whether there's any chat function enabled. If you have chat function enabled, can you just type it in the chat window, or else can somebody speak what's the name of the device I'm holding? Anyone? I'm not really sure whether how many of you were actually born before these days where this device were actually quite active. Can someone tell me the name of this device? Okay. Sorry. Look, this device, by the way, this device name is floppy disk, okay? And
जो नहीं आ रहा है शायद मैंने गलती से उल्टा पुल्टा डाल दिया.
cool. Yeah. Look, there. Since you don't have the chat window, the can someone actually tell me what's the maximum capacity of the floppy disk? A 5.4-inch floppy disk or a 2.4-inch floppy disk? All right. Look, the thing is, so it's about 2.4 megabytes. Sorry, 1.4 megabytes. So the reason I'm actually coming to this, I was talking about this floppy disk is that this was such a days where I used to carry 10 or 20 of them just to download some stuff from internet and then carry it and then put it on my PC. Okay, this was 20 years ago, and I used to install Microsoft Office with I think it was about 25 or 30 of them. And the funny bit is that you have to insert the first floppy disk in a sequential manner. Okay, otherwise the Microsoft Office will not install on your PC. So those were the days where the storage was very constrained in the world. But these days you can get a floppy disk. No, you won't get a floppy disk. You won't get a CD disk. You will get buy a small USB for less than $1,000 that can hold up to 32 GB or even more than that. This was about 1.44 megabytes. Okay, think about that. Okay, so the world has actually changed. How the world is actually changing is, if you look at it, the data is actually, the amount of data we produce, the data volume is actually growing exponentially. This is a chart I picked from IDC, and if you look at from 900s to till 2019 or 2020, the volume of growth is exponential in nature. We've gone from gigabytes to zettabytes and even more beyond that. Okay, and we want to understand why the data is actually growing at this rapid pace. So the main drivers are, the first one is compute power. In those days, 20, 30 years ago, the compute power wasn't that great. Okay, we used to be in 700 megahertz processor. These days, you get a quad core 2.4 gigahertz. Okay, so the compute power actually has grown. That's actually driving how much data can be processed. So this is on the processing power of things. And the second thing is on the internet speed. I used to have a dial-up modem where it actually makes funny sound when you're trying to connect to the internet. But these days you can get a high-speed internet in your mobile for a cheap price. Okay, so that's the power of internet speed. in terms of driving how much data we can actually pull through the network. Okay, and the other main reason, this is one of the primary reason I would say that causing the data volume to explode is the smartphone usage. So 20 years ago, there is no concept called smartphone. We used to carry Nokia phones where the only option for us to connect with people is through mobile call or through a text message. But these days, we hardly text anyone. We WhatsApp someone using internet, right? Or Facebook or Instagram. We use all those apps, and that uses data on data packs behind the hood. So these three are the main, even though they are the key drivers. I would put smartphone as the primary driver for the data growth. Okay, and the other one, if you look at the way the data actually grown, the data volume actually grown. If you look at the cost factor, okay, the storage cost is exactly the same. Okay, when I say exactly the same, the cost per gigabyte actually come down very rapidly. Okay, literally it's zero to store something in the internet. If you look at Google, they provide Google Photos and other services for free. Okay, up to 15 gig you can actually store. And there are other email providers where they actually offer you generous data storage. Okay, I used to buy this floppy disk for, I think each floppy disk it's about 100 rupees. So if you buy 10 of them, it will cost you 1,000 rupees. Okay, these days you can get 32 gig for 1,000 rupees. Okay, so the cost per gigabyte actually gone down. The second one is the bandwidth cost. We used to pay hefty, exorbitant amount of money to buy a dial-up connection, which is about 128 kbps at the max. I used to get 64 kbps at my home in my early days. But these days, if you throw 500 rupees, you can get a broadband, like a 40 Mbps connections. Okay, the broadband cost actually gone down. Okay, so the speed per bandwidth cost actually gone down. Okay, the third main factors driving the data growth is in terms of the component industry. So these days, the amount of component you need, how cheap it is to produce a mobile phone is extremely small. Okay, so there are cheap components available because the technology has actually exploded and bring the cost down for all this tiny electronic components to be manufactured. So these three main factors coming with this complementary factor on the cost is actually driving this exponential data growth. So let's move on to some high-level statistics. So if you look at the population at the moment in 2020, we are in 2021. So last year's population is just an estimate. We have about 7.8 billion people in the world. Okay, and out of which there's about 60% of them are connected to the internet one way or another. There's a lot of developed nations where the penetration of internet or the mobile internet into their population is close to 96 in all the developed countries, which is amazing, which means everybody is connected. So if you look at the number of devices, when I say devices, these are connected devices. It could be a mobile phone, it could be a smart device you have, it could be a Fitbit, or it could be anything that's connected to the internet. That stands about 75 billion. Okay, so there is about 75 billion these devices. So if you could roughly divide it, so there's about roughly 9 devices per person in the world. This is amazing. This is really a big number, 9 connected devices per person in the world. So if you have a house of 4, so you're already looking at 36 devices in the house. Okay, everybody's connected to that. Oh, look, this is on the average, but this gives you an interesting idea. So if you go home and then you look at how many mobile phones you have lying in your desk or at your home, it really mesmerizes you how much devices you have, and your smartwatches, your Fitbits, your set-top devices or your computers and things like that. It is growing at a rapid pace. And guess what? All the devices you hold is generating data one way or another. Okay, so let's do a quick kind of a calculation in terms of how much data is actually producing. So let me go back. Look, let's say that instead of 9 devices, they have 7 devices, and each device is actually sending 1 byte per second. And if you look at it, it's actually built, it's come to 100 megabytes a day. Okay, it's not a big deal. But if you look at a considerable population, let's say 2.6 billion people have access to the internet. I'm making a moderate assumption here, and it's about 260 billion megabits per day. It's a huge amount of data, just data, few data. And for example, I would say 30 to 40% of this big data is being captured by close to 10 or 15 companies in the world. For example, Google, Netflix, Amazon, Apple, they capture a lot of data. So my question to you is, what do we do with that massive amount of data? Can anyone unmute yourself and then think about, I mean, these companies are generating this much amount of data. What do we do with it? What do we do with that amount of data? Anyone? All right, let's move on. Look, so if you look at it, the companies who are actually the massive consumers of this data they are the ones who actually capture this data. What do? They really want to make money. Okay, they really want to use this data to change their business model, to build new products and services so that they can actually offer more customer centric and then personalized services. Okay, that's exactly what many companies do. So the primary function, or not a primary function. So the way they actually monetize data is through this. In those days, many companies just sell a product or they sell the services. But these days, they actually monitor how you're actually using the product or using the services. Then they can actually tailor or personalize some of those services and products just for you. And they also want to shift their business model around in terms of how they can actually monetize, go into different sectors and things like that. So that's what many companies do with the data that they actually collect. Okay, so this is about the companies. What's in it for me? What's in it for the customers? So if you look at it, we get some value out of the data we actually share. Okay, so of course there is some data privacy concerns. A lot of organizations actually come to realize. In terms of big government organizations like European Union, they have strict data privacy laws on how much data we can actually collect and share. But there is a value proposition for the customers in terms of the more data we share, we get something back. Okay, not more data. The data we can share, obviously, we reap some benefits out of it. So I'll put on two high-level things. The first high-level thing is in terms of for the customers, it saves time. So the data we share, it saves time. Give you a quick example. You open up your Uber or any kind of taxi hailing apps. You share few data with them. For example, you share your name, you share your phone number, and more importantly, you share your GPS location when you turn on that app. And one more important thing is they also capture time when you're trying to book a taxi. Okay, so you share that data with taxi hailing apps. What do? They take the data and then they match with the available taxis that's very close to you, and then they come at your doorstep and then they pick you up. So ultimately, it saves time. Think about those olden days where 15 or 20 years ago, you have to ring up a taxi operator and then you call. And then you explain them, look, you need a taxi on this day, at this time, and they have no idea where to find you, and then they have no idea about when they're gonna get to your house. So these things are completely avoided. What it actually gives you is saving time, which is very, very important in the modern age, saving some people's precious time. The second thing for the customer is we are all connected. We are all connected instantaneously. We are all connected in real time. So if you got any message or if you're going on a vacation and you want to share something, all you do is take a picture and post on WhatsApp, and then now it's literally broadcast to the entire world. So that's the power of this data collection and the ability to actually disperse the information in a very quick way. And it makes our life easy and simple. It's very, very neatly done in terms of the data we share. So the more there are a lot of people who wants to share more data with companies, that's fine. And they use the data to actually personalize services for you. For example, YouTube and Facebook and Instagram, they collect more data so that they can actually tailor the content for you for your own personalized needs and your preferences. So that's about in terms of data collection. Look, this is about a generic introduction into big data and data collection, stuff like that. But how it's relevant for engineering students like you, how the big data is actually changing the landscape of engineering discipline. So that's very, very important. Okay, I'll walk you through some use cases and then come back to how it's actually changing each discipline in engineering, especially electronics engineering in a more prominent way. Okay, let's take about smart home. So you probably heard about smart home. Smart home is the concept, and it is already been implemented in the world, where you try to control everything around your home using an app. It's as simple as that. So what are the things you do? So you monitor temperature, the chillness in the house, and then the moisture content in the house and stuff like that for your comfort. Okay, so that's the thing we do. And then you can actually turn off the lights. You can look at the security aspect of it if you connect to some webcams and things like that. And the other more important thing is in terms of energy savings. So if you can automate somehow in terms of how efficiently you are using the electricity in the house in terms of electrical appliances, you can save cost. And if you can powerfully utilize the solar panels you put on the roof and then able to switch between on and off the grid for electricity supply, that also saves you money. Okay. And then the other important aspect is to the security. If you could hook up all your security cameras to the smart home system, then obviously you're protected, you're safe in the house. So this is a typical application in a smart home. But if you look at it, every single sensor in a smart home is actually generating data. It's actually streaming data. It actually captures data and then streams into a central location. So that's what it's doing. Either it's temperature or moisture or wind speed or outside temperature and things like that. It's constantly being fed into a intelligent machine behind the scenes. Okay, and it is running powerful mathematical algorithms to make decisions on your behalf because you allow them to do so. Okay, and you can actually control as well. So you have a control at your thumb, right? You have your smartphone app installed on your mobile phone or your smart devices, and then through which you can actually control. So that's the power of using data for your own comfort, safety, and convenience. So it actually eventually, if you look at the next use case, which is about cars. So in those days, if you look at a car is a typical mechanical and an electrical devices with some electronic components to it. This was the 20, 30 years ago's generation of cars. Okay, so the typical example in India is the Hindustan Motors Ambassador car. So if you look at it, it's a giant metal piece which is solid, right? And it has some electrical components and some electronic components to it. That's what it is. But these days, in the 21st century, all these cars are made customizable. And because of this climate change and eco-friendliness coming into picture, no longer we use fossil fuels. So ultimately, the cars are actually shifting towards electric vehicle market, where this electric motors is the primary power producers in the car. Okay, and guess what? Everything in this modern day cars is software controlled. So the software controls the cars. So this amazing shift in terms of how we transition from a mechanical engineering kind of domain into strictly into electrical, electronics, and software. Okay, just in terms of cars. Okay, so that's the use case I could give you on the role of how the the industry is shifting and what kind of data is actually produced. Typical example, if you take Tesla Motors, which produces Tesla cars, there is no engine. Okay, the engine, they have DC drives, so essentially they have DC motors, and they have sensors placed all over the car. And guess what? Because it actually, because the sensor actually did everything around the car in terms of they have radar sensors, they have sensors mounted in the front, which has some cameras at the back, and it also has the LiDAR sensors, and it also have ultrasonic sensors and stuff like that, which enables the software to use this data to make some decisions. For example, in the United States of America, the Tesla supports autopilot mode. Okay, literally you can actually take your hands off the wheel and the car can drive by itself. And the more important feature in Tesla cars is that it is personalized just for you. Okay, everything in the car can be personalized to your settings. If you got in and you know your seat positions, your temperature in the car, how you want everything to be adjusted to your preference, it will do it just for you. Okay, this is like having multiple profiles in your Windows machine. So if you log in, you have your own desktop view and wallpapers and other settings. If your friend logins your computer or your family members log into your computer, they have their own preference as well, so it can actually change. So the same kind of concept is applied to the cars. Okay, so it is customizable. This is one of the things I can actually show you in terms of personalization. The whole car is there's no the dashboard is a giant screen, so it's a touch panel, and you can actually configure everything for you that suits your needs. Okay, and everything is customizable through software. You can actually see there is no knobs. Everything is touch based. Okay, which is the new kind of user interface. And the other application I can actually give you in terms of how electrical engineering or electronics engineering plays a role in power generation is in terms of microgrids. So there are a few big installation of this Tesla microgrids in the world, and South Australia in Australia has implemented Tesla microgrids. Okay, so this is to avoid power outages. So essentially, they use solar panels. So they produce a lot of energy during when the sun is shining, and they store it in a batteries. And whenever there is a demand, obviously the batteries can actually discharge. So that's how they actually manage. And guess what? Everything in this microgrids is controlled by software. So coming back to our own homes, the electrical appliances, no longer we buy tube lights or electrical bulb, which is halogen based. Everything is LED now. We are moving into energy efficiency space. Okay, and guess what? If you buy this Philips Hue lens, and they come with an app which can be hooked up with your Bluetooth or Wi-Fi, and guess what? If you feel like you want green color, sure, you can have a green color in your house. Okay, with the lamp, the light, it will emit different colors. Okay, so you can actually customize colors to suit your needs. Okay, so everything is customizable now. All right, so I've given you some examples. I've given you some brief introduction about the data growth, how it's been channeling the industry, and also given you some use cases in terms of how the data is actually changing all the electrical engineering discipline in terms of appliances, machines, and stuff like that. And there's also aspects in terms of telecommunication, which I'll go next. But what's next is, if you sell some services or appliances or machines to the people, right now, understanding and monitoring how people interact with these objects or appliances or the services is the new frontier for innovation. Okay, that's typically how the world is actually changing. The way they actually do that is by collecting data. Okay, so they sell you some stuff, but under the hood they will collect some data. Okay, in terms of how you're actually using it and where you actually taken the devices to and things like that, and use the data to actually tailor some services for you, just for you, so that they can actually monetize that. So if there is any value they see, that's what they do. I'll give you a quick example in terms of business model. Those days, they just sell things alone. These days, they sell services along with the things. That's the new way. I'll give you a typical example though, so you can actually relate to. In those days, they sell washing machines, right? It's a standalone device. It's just a washing machine. You plug it to your power outlet, and it just washes the clothes. That's it, and it dries your clothes and stuff like that. That's what it is. But these days, if you look at some of the smart washing machines that come out in the market, the way they do things is a little bit different, right? They sell you washing machines, but the thing is, you have to hook up your washing machines to a Wi-Fi network, or sometimes they sell with your embedded SIM card and things like that. The reason is they will look at when you're actually using it. Okay, so the data they collect with that smart washing machine is that they will collect data such as when you're actually using the washing machine, how much power actually dissipated from the washing machine, how much water has been consumed, dissipated, what's the wear and tear of all the components inside the washing machine and things like that. Okay, the reason they do that is this. So if they collect the data and they know, using the data, they can actually predict when the washing machine motor is going to fail. They can preempt that, because if you're using for a heavy loads for a long period of time and you're not taking proper maintenance and things like that, before it actually fails, they'll ring you up and say, sir, your washing machine is going to break down in a few weeks time. Can we come and replace it to you? Okay, and you'll be delighted, right? You'll be completely delighted because you've been watching this motor is making funny sounds or things like that. Then you quickly go and then, yep, take that offer. What they do is they will bundle the services along with the washing machine. So instead of selling the washing machine for 10,000 rupees, they'll say you pay 8,000 rupees for the washing machine upfront, but you pay a recurring of 600 or 800 per month or per year for this value-added services, and you'll be delighted. Okay, most of the customer behavior is actually changing towards that, and this is literally underpinned by the data, okay, and the mathematical algorithms. That's the new way of selling things. In terms of, since most of you are electronics and communication engineers, I can give you another prime example. Those days when you go on buy a mobile plan, okay, mobile phone plan, they'll only say, sir, for this much rupees, you can actually make this much of free calls, or your outgoing history, incoming history, and things like that. But these days, if you go and buy some services, what do they give? They'll give you Hotstar plus Disney for free, or they'll give you Amazon Prime for free. So they try to bundle up services into your existing product or services, so you can actually get more value. At the same time, they're actually collecting more data to provide you more services, okay, or tailor some services for you. So that's exactly the shift in the business model in terms of how these companies operate, and it is a win-win for both the customers and the companies. But as long as you make sure that the data privacy is respected, okay. I've given you an example on the smart home automation. So I will move on to how this data is actually powering some intelligence inside the smart home. Okay, so let's say you have all this smart home sensors put in your house. Okay, you use, let's say you wake up at 3 a.m. in the morning, okay, just to go to the toilet. And if the algorithm detects that you woke up, what the algorithm will do is it senses actually an anomaly in the pattern, right? You turned on, and what it'll actually do is that it won't blow the light at 100% intensity. It will blow at 40% intensity. Why? Because it's the middle of the night, and if you want to go back to the bed, you have to get back to sleep, right? And for that, it actually blows the light at 40% intensity, and once you come back to bed, obviously the air conditioning is pretty much tuned so that it will give you maximum comfort, so that you can actually fall to sleep very quickly. So this is usually a typical use cases where you can actually see the sensors actually collect data and they send the data to the cloud. And in the cloud, they run some mathematical algorithms, and then it actually sends back the command to your smart home kit, and then it actually says blow the light at 40% intensity, and then tune these factors in the AC so that you get a maximum comfort and you can fall back to sleep. Okay, so that's the power of the data, and then the use of compute power and the storage power in the cloud, and the mathematical computation actually low on the cloud in terms of applying mathematical algorithms. And then once you've done some calculations, and then you push the decisions back to the local kit, or the local intelligence is in the smart home kit that's placed in the house, and then that enables it to act and make some decisions. Okay, so that's the whole idea behind how much the smart home can tailor and personalize things for you. Okay. So in terms of idea behind why we send data to the cloud, and why we act locally, why can't we just do that mathematical computation inside the local, is for two reasons. The first, for three reasons. The first thing is we want to save power. All the smart home appliances and the devices, the kit you have, the local intelligence unit does not have much compute power, okay, at the heart. So you send the data to the cloud. Obviously, the cloud offers elasticity, so it can actually have unlimited. Theoretically, hypothetically, you can have unlimited compute power in the cloud. So we want to capitalize on that. That's one. The second thing is in terms of power consumption of all this device. In terms of the local devices. So obviously, if you want to run more calculation, it takes more power to do that. Obviously, if you go to the cloud, this problem is solved. And the other main factor is, since it's all mathematical formulas and it's running on a big chunk of data collected from a lot of people and from a lot of sensors, it makes perfect sense to store this big chunk of data in the cloud rather than in your own PC or in the device. Okay, so we just want to capitalize on on the power of cloud. So just to give you an idea, since you are electronics engineers, how this big data architecture is evolving is that you have all the sensors. That's the first layer. That's the one that we use to sense data from the real world. It could be temperature monitoring, or it could be number of clicks we make on YouTube and things like that. So it's pretty much the sensors that actually gave this data. And then you can talk about this local connectivity in terms of how this devices, sensors and actuators communicate with the local intelligence unit. That's through the local connectivity, because we use few technologies like Bluetooth, NFC, and things like that. And then the next layer is you have to connect these devices to the internet. So there's a gateway you need. For that, you use a GSM, Wi-Fi, or LTE, which is the 4G network, and things like that. And then on the top, you have management services. That's where the cloud comes in. That's where you apply data security and things like that. And then you run some strict data privacy and data management things on the top. And then on the top is the application layer, where you have apps and web apps. So that's what we expose to. So behind the scenes, we won't have anything. We won't see anything just from the consumer angle. It's all abstract. We see magic happening. For example, we take an app and then we press a button, and then suddenly the color changes to green. Okay, so we see that there's a magic, but behind the hood, these are the things that are actually taking place. Okay. So in terms of how big data gets processed, is that all these things stream data. They produce a lot of data. Okay. It could be measurements. It could be anything. Okay. These are all called data. These are generated from things or appliances, and then it is streamed or taken from things to the big data platform, which is usually residing in the cloud. Okay. And that's where we throw a lot of compute and storage, and we apply a lot of mathematical algorithms and things like that. And then using that, we actually automate a lot of decisions. Okay. So this is the typical flow of how the data is captured from a device and turned into an intelligence, so that we can actually act on it. So coming back to this intelligence piece, mathematical algorithms. So this artificial intelligence is a very big umbrella term that encompasses this machine learning as well. Machine learning. So essentially, it's how do we tell the machine or program the machine to think for itself. So that's the genesis of artificial intelligence, because we can program a computer in a very rule-based way, and then let it execute some things for us, make some decisions. But how do we actually enable the machine and then make it learn by itself? That's the genesis of artificial intelligence. So there's no need to teach it. I mean, there's no need to program the machine. Okay, we program the machine so that it can teach itself. That's the genesis. In a logical way of thinking, what an artificial intelligence can do is three basic things. It is very good at forecasting. So if you give us the past data, or you can use the previous or the past data to actually forecast what's coming in the future. So it can do that. The second thing is it can do classifications. So if you give pictures like cat and dog, it definitely can classify which is the dog and which is the cat. Okay. Or if you can give some chess, it can definitely learn those underlying patterns of moves and things like that. It can definitely learn how to classify. Okay. The other thing is it can also, if you don't know anything about classification, if you want to cluster it, for example, you have a lot of data and you want to understand patterns, so it can definitely do that. Okay. So these are the three main core ideas artificial intelligence can do: forecasting, classification, and then the pattern recognition in terms of clustering. I'll give you a typical example for electronics engineers in terms of how this all these three big topics I've talked about, three main areas of AI is in play. Let's say a small microprocessor is actually producing doing some lot of compute, and it's taking a lot of power from a DC power supply, and you want to forecast how much power it's going to consume in the next minute. Okay, just to forward plan, you can definitely do that. Depending upon the lot of variables that's involved in this power forecasting, right? We can the ML model, the machine learning model or an AI model can definitely do that. And the other thing it can do that is in terms of anomaly detection. Let's say we consume 50 hertz electricity in our house. If there's any kind of anomaly in the 50 hertz frequency, an ML model can definitely sense that and then alert. And in terms of classification, let's say you have a lot of data that you have collected in terms of the power generation and utilization from commercial companies and the housing market and things like that. And then once you throw this data to an algorithm, you can actually say, by the way, if I found these patterns and this pattern belongs to industries, I found this kind of patterns that belongs to the household consumers. So you can use this data to actually pattern match or cluster. Okay, so then you can actually make decisions based on that. Look, before I wrap up, I just want to summarize what we have learned or in this one on our webinar, that the key takeaways are the things and appliances are actually generating massive amount of data. The things can be your mobile devices, or it could be any kind of appliances at home, or it could be a car, it could be anything. Okay, as long as the things, they're generating a massive amount of data. And all this data, the big data is actually generating, is the key driver for innovation. There are a lot of companies use this data to build new products or new services, and they customize and tailor services to the consumer needs. Okay, just to give you an idea, if you as an engineer, you want to get into this big data field or machine learning field, it's a hot topic at the moment. It's definitely a go-to place if you want to get a good job with high salary. In terms of knowledge required to upskill yourself is in terms of have a good knowledge about Internet of Things. You should be having good knowledge about how to hook up a lot of sensors to a device and then stream data. Okay, and I have good knowledge about big data platforms. I would ask you to upskill yourself in the cloud. For example, there are free courses available from Amazon Web Services, who is the dominant player in the cloud, and then there's another one. Next player is the Microsoft Azure, and the third one is the Google Cloud Platform. Okay, so these are the key players in the market. I would definitely ask you to go and take up those free courses and then get familiarized with this big data platforms and the technology in the cloud. The second important thing you should be focusing on in terms of machine learning algorithms. Remember, I talked about these three kind of general things that AI can do. Obviously, if you look at the bottom of the slide, I've given you algorithms, few algorithms for forecasting like regression and neural network, classification, k-means, and random forest and things like that. So make yourself familiar with this machine learning algorithm on how to apply, when to apply. Obviously, you might need some knowledge on mathematics and statistics, but definitely make sure you learn a programming language for machine learning. Obviously, I would recommend Python, but R is another language you can actually learn as well. So that's pretty much I've got. By the way, if you want to have play with this data, there is some links I've provided. There's some IoT data sets I found in the web. And the other data you want to play with this is that Indian government of India, they have an open data portal, data.gov.in. If you go and type some keywords on what kind of data you need, there is some data sets available in the portal as well. So that's pretty much I've got. Happy to take a few questions. Any questions from anyone? If you could unmute yourself and then ask the question, happy to answer.
Thank you, Silva sir, for the presentation. I had just one question regarding the presentation, not just regarding your presentation, regarding big data. Your experience in the transport domain in Australia, how can we apply that knowledge? How it will be useful for us? Because in India, as everyone knows, there are a lot of accidents that are happening in India. So your knowledge of big data that you have acquired from Transport Australia, how can that be used to prevent accidents or improve the infrastructure in our country?
Yeah, look, in terms of the first, definitely the safety is the prime thing that we should be focusing on our roads. We have to understand what is the root cause for all these accidents. Is it because of non-compliance with the road rules? So that's the first thing we want to understand. When I say non-compliance with the road rules, probably are we riding too fast in a speed zone, okay, where it has a set limit of speed? That's the first thing we want to understand. The second thing is in terms of how people are actually adhering to all the other rules, other traffic rules, in terms of making sure they're actually stopping when there's a red light, and then ensuring that when they change the lanes, they put some indicators on, and then they change the lanes and things like that. So those are the thing root causes we need to hypothesize and then have this hypothesis, and then we need to collect data to support that or validate the hypothesis. We need to find evidence for which the data collection can be done by putting some sensors on the roads. For example, we can actually mount a camera in the typical road signals where the accidents are high, and we can actually observe how many vehicles are actually passing through, what's the speed of it, and how many people are actually non-compliant with traffic rules and things like that. And then after that, we can actually use the data to find evidence, and then after that we can actually reinforce. That's something we can actually do. That's on the in terms of operations side, but definitely on the planning side, if you know that there are more traffic accidents happening and we know that we need to build a bridge or we need to think about traffic, altering the traffic and things like that, that can also be done using the data and then using some machine learning algorithms. And the machine learning algorithm actually tells you the route. It can actually optimize the route for you. It will pick the route where the traffic is less, or it can give you, in terms of planning, it can actually tell you what's the optimal way to lay a road or a bridge and things like that. It can definitely help. And the more data you give in, and then the more data you actually collect for solving hypothesis, it will definitely strengthen your decision making capabilities. Yeah, look, just because you guys are doing electronics and communication engineering, the typical example I can actually give you on the location of cell phone towers. So if you think that the many mobile operators, they put up towers at the random, you're completely wrong. They actually exactly know where to put the cell phone towers so that they can reduce the outages, okay, in terms of blind spots in their network coverage. So they exactly know. So they exactly know within certain radius where to put. So that's exactly how they actually pace it. It's all done through mathematical algorithms. Okay, these are all optimization algorithms running in the background. They collect data and then they know where to put it. Okay, and they run some simulation models and things like that. So it's all underpinned by data and mathematical algorithms. Any more questions before we wrap up?
Thank you, sir. Any more question from the participants? Any more question?
Yes, sir.
Yeah.
Yes, Bhavika. Bhavika.
No, sir. Thank you.
Okay, okay. Selva sir, I want to ask about the big data. What you have mentioned in your presentation, the smart grid. In that scenario, also the big data and its analytics is very important. So, for our students, just let us know what is the future scope for electrical technology also, as far as the big data is concerned. Yeah. Yes.
Look, for electrical engineers, if you just look at that segment, so I see disruption of in three main domains just on the electrical engineering of how this big data is going to play a major role. The first one is in terms of the power generation, okay, or distribution and transmission. Big data will play a huge role. In terms of power generation, if we can actually anticipate how much power we need in the future, definitely we can actually foreplan. Okay, for which the big data is actually literally helpful. Understanding the demand of the future demand of the consumers, and then so that you know exactly how much power you need to generate and which machines you can actually put in a maintenance mode and things like that. You can actually forward plan. That's one. In terms of transmission, if you want to identify where you're actually losing power along the transmission lines and understand where the power losses are, you can definitely use big data. You can actually collect data on while the electricity is being distributed or transmitted. In the distribution side, definitely look at what the consumer demands are every hour. We can actually understand the patterns of their consumptions. So that's on the power side. Okay. The second aspect is in machines, the DC machines and AC machines. No longer the motor is an electrical device. Okay, I can make that bold statement. The reason is you will have a lot of sensors fit to it. You will monitor its electricity, its current, its vibration, its how much frequency, the frequency of electricity is actually consuming, the wear and tear, the noise sensors. It will be built into the motor so that we monitor the health of that DC machine. Okay, and we will quickly identify before it actually fails and things like that. Okay, or put in the maintenance mode very quickly. Okay, that will happen. That's the second area I'm seeing. The third is in terms of electrical appliances at our houses. You talk about electric bulbs, washing machines, microwave ovens, TVs, you name any electrical appliances at home, it will have sensors built into it, and it will generate data, and it will customize services for you for your needs. That's the three main areas I'm envisaging that will have impact. And as an electrical engineer, make sure you understand the electrical engineering electronics aspect of it in terms of sensing. And definitely, if you want to switch your career from electrical engineering into big data, that will have a huge kind of plus. The reason is many of the people who actually do this big data and machine learning and things like that, they don't have domain expertise. Okay, when I say domain expertise, they're not electrical engineers. They don't understand how a electric model actually works, but they can actually see the data and then they can build some algorithms. But if you are a machine learning engineer or a big data engineer with some electrical engineering domain knowledge, you just stand out. Okay, you can run a lot more sophisticated algorithms and understand the business context or understand the domain a lot more, so you exactly know what's happening in the electrical device itself and what these algorithms are actually doing and things like that. So I would definitely encourage all of you to learn about machine learning and be strong in mathematical fundamentals, and also on the electronic side, make sure you understand how this sensing and the IoT world, the Internet of Things world actually work, and you can actually design something. So that's the future I'm seeing. Hope I answered your question, sir.
Yes, yes, sir. Yes, sir. Thank you, sir. Any more question? Any more question? So can we conclude here from a participant side? Yeah, yeah.
Sir, do we need to do any certification course on this big data?
Yeah, look, it's yep. Look, you can. The thing is, if you really want to get into this big data, it's a really a wide, it's a big field. So if you're really looking for any kind of certification in this domain, I would rather advise you to go to these three main big providers. For example, if you go to AWS, Amazon Web Services, and you type for big data or machine learning certification, they offer free courses, but for certification you have to pay a fee. If you go to Microsoft Azure, they also offer something similar. And then Google Cloud Platform, they also have a lot of certification available. So these are the three main major providers of cloud platform and big data platform. I would definitely go and get some certification. It will definitely help you with the career and your job prospects. It's a hot wanted, it's a hot topic in the world in India at the moment. If you're certified in this big data or machine learning, you will definitely get a job. Any more questions before we wrap?
Good morning, sir. Shubham here.
Yep.
So, sir, once again, I would like to repeat, you said AWS, Microsoft Azure, and could you please repeat the last one?
It's Google Cloud Platform. Google Cloud Platform.
Okay. Thank you very much, sir.
Okay, can we conclude? Any more question? Yeah. Thank you, Selva sir. Myself, Professor Dipak Raskar, on the behalf of Bharati Vidyapeeth College of Engineering, Navi Mumbai, and a department of AXTC, we convey our sincere thanks to you. Thank you for sharing your knowledge about various phases of development, right from a floppy disk era to our IoT era. We definitely believe our students would have been inspired by our insights. Sir, we hope that in future also you will support us for such interactions. Also, I would like to thank all the participants for attending this webinar and making this webinar a success. I also would like to thank our principal, Madam Dr. Sandhya Jadhav, our HOD Professor P.A. Kharade sir. We have permitted and motivated us to organize these seminars. I thank all my department colleagues and faculty from other departments also for supporting us. Thank you very much, sir.
Thank you.
I think the student experience.